Hello, I'm going to continue with that what I've started in the version control. So I'm going to move the scenario 5, which is fixing merge conflict. So I'm just going to start the scenario here. Start the scenario. Okay. So there will be 6 steps, and the step 1 will be JIT merge. So at first, we have to use the JIT fetch command, download change into a separate branch, which can be checked out and merged. So during a merge, GIT will attempt to automatically combine the commits. So when no conflicts exist, then the merge will be fast forwarded. So then you won't have to do anything. So if a conflict does exist, then you'll retrieve an error and the repository will be in a merging state. So in your environment, the changes from a remote repository has been fixed. So you now need to merge the changes from the origin master. So this will result in a merge conflict. The conflict indicates the merge failed because both repositories added the file. So well resolved this in following next step. So by keeping commits in small focus and you reduce the likelihood of a merge conflict. So it's going to use the complete step to execute that code. As you can see, use the file and it's merge conflict in staging.txt. So says automatic merge failed and fix conflicts and then commit the results. So just continue to the second step, which is viewing conflict. So when a conflict occurs, the changes from both the local and remote will appear in the same file in the Unix diff format. So this is the same format used by gdiff. So let's go and move to the third part, which is resolving conflict. So the simplest way to fix a conflict is to pick either the local or remote version using both. So I'm just going to run the command here. So if you need to have more control, then you can manually edit the files like so just run the file here. There will be tasks like git add and git commit. So simple solution. So first this command that I used and to apply for the staging, you have to use this command right here, and then for the audit one we have to run this command as well. So I'm just going to move to the fourth step, it is non-fast forward. So this simulate to a non-fast forward merge, the following has occurred. The first one is developer A pulls the latest changes from developer B. So the developer B commits change to their local repository. So the developer A commits non-conflicts changes to their local repository, and developer A pulls the latest changes from developer B. So in this scenario, Git is unable to fast forward the changes from developer B because the developer A has made a number of changes. When this happens, GIT will attempt to auto merge the changes. So if no conflicts exist, then the merge will be completed and a new commit will be created to indicate the merge happening at the point in time. So these tasks are the pull changes from the remote repository and use the default commit message using the command below. So I'm just going to use the command to run this file. And after that, you can view the commits with JTlog or decorate online. So I'm just going to continue with this. So in step 5, which is GIT rebase. So the merge commit message can be useful to indicate synchronization points, but they can also produce a lot of noise. So for example, if you are working against a local branches and haven't pushed, then this additional information is meaningless and confusing. So to other developers looking at the repository. So to do that, these commands will be useful, and let's go to the sixth step, which is rebasing in rebase. So This approach also applies when working with remote branches and can be applied when issuing a pull request using this. As you can see, there is not track information for the current branch. Please specify which branch you want to replace it. So that's all for the fixing merge conflict, which is scenario 5 in GIT. So it's going to move to the next scenario, which is JIT control experiments using branches. So just going to start this scenario here. There will be 5 steps, which is I'm going to start from step 1, which is creative branch. So in this task, we have to create a based on another branch. So generally master the command is this: the creative branch, the new branch name, and the branch that you are going to start. So to switch to a branch, you can use this JD checkout, the new branch name command. So the task is to create and check out a new branch called new branch. So we have to copy these to the branch name. The command is JD checkout b new branch name. So let's try out this here. The new branch solution. So because this is I have already hit a new branch and it exists. So the checkout command it say checkout new branch is already a new branch. So that's all for the first step. So I'm going to move to the step 2. So in list branches you can have a list of the branches using the git branch command. So here are the other branches, the master and the new branch which I created a few seconds ago. So our task is here to list all the branches with their last commit message using the git branch. So it's going to run the command here, and it's going to continue to the third step, which is merge to master. So to that, the commit has been made to the new branch. So to merge this into master, you would first need to check out target branch. So in this case, matters master, and then use the git merge command to merge in the commit from a branch. These are the commands that we're going to use here: the git checkout master command and the git merge new branch command. So at the first command, you already switch the branch master, and then we're going to merge both. So it's updating the file. The thing. So it's moving to the fourth step. As you can see, there's the link. So as we discussed in previous courses, if you want to push to branch remote, then use this command. So in the final phase, cleaning up the branches it's important to remove the amount of noise of confusion. So to delete a branch, you need to provide the argument -d branch. So as for instance, we take the new branch. So So as you can see, the message was saying deleted branch, new branch. So the new branch has been deleted by this command. And that's all for the scenario 6 experiments using branches, which is GIT control. And just going to move to the scenario 7, which is finding bugs. So there'll be 4 steps. The first one I'm moving to the is jetty-diff to commit. So the jetty-diff commands is the simplest to compare what's changed between commits. So it will output the difference between the two commits. So as you can see by this command, you can see this. So I'm just going to continue here. So jetty log will be helps you to commit messages, but by default it does not output but actually change. So thankfully the command is extremely flexible and the additional output provides useful insight into the history of the repository. So to see the overview of the commits in the short view, use the command jtlog online. So as you can see the files here. To output the commit information with the different of what change, you need to include the peak remote such as this. So it shows in here too. So this will output the entire history, so you can filter it with a number of different opinions. So by this command, you can see that too. And using this command will output all the commits list, which includes the word initial in the commits message. So this is useful if you tag commits with bug tracking numbers. Just going to run the command here. So you can see commit the author and the date. Just going to move to the third step, which is bit bisect. So there are a few steps to follow that. So it actually means that the git bisect command allows you to do a binary search of the repository looking for which commit introduced problem and regression. So in this step, we'll find the commit which forgot HTML tags in the list.html. So to enter into bisect mode, you use the command which is get bisect start. It's going to start the command. Once the bisect mode, you define your current checkout as bad using JT bisect tags. The command here. So this indicates that it contains the problem you're searching to see when it was introduced. So we've defined where a bad commit happened, and we now need to define when the last non-good commit was using with this command. In this case, it was 5 commits ago. As you can see, 2 revisions left to test after this. So it's going to call this HTML to fix the step 3, which check out the commit in between bad and good commits. So you can then check the commit, run test to see if the bug exists. So in this example, you can check the content using the command cat list.html, and you can see in here. So this commit looks good as everything has corrected HTML tags. So we tell JT we are happy using git bisect good command, which I have to okay. Bisect me 0 revisions left to test after this. So again, we have to check the list. So you can see this here. And this commit has missing HTML tags using and we let the search and output the related committed ID. So the result is that instead of searching 5 commits, so we only search 2. On a much larger time scale by set, you can save your significant time. It's time to move to the fourth step, JIT blame. So while having a blame culture isn't desirable, so it can be useful to know who worked on certain sections of the file to to help with improvements in future. So this is where the JT blame can help. Example, get JT blame is the HTML here, this command here. Then if you know the lines which we are concerned with, then we can use the dash parameter to provide a range of lines to output. So dash L, this you can see parameter as output. So, and that's all for the scenario 7, which is finding bug in JIT version control. And now I'm going to move to the scenario 8, being picky with GIT. Let me start the scenario, which it has 3 steps. Step 1 is cherry picking. In the scenario, we have a number of commits in the new branch which has created 2 HTML files. In this scenario, we only care about changes to one of the files, but if we merge the branch, then we merge all 5 commits and unwanted changes. So the task is to follow the steps below to the merge and 3 commits and randomly cherry pick the commit with the message initial commit no items. Cherry pick the commit with the message initial list and the cherry pick the commit with the message adding final items to list. So let's go to continue. So into the second step, which is resolving cherry picking conflict. So we have to do first, if you have to cherry pick the creation of the second list using JT cherry pick new branch. So this one is solution. It's much easier. So we have to cherry pick the new branch one. Just using that, and we have to check the status after that. So as you can see here, we can on your branch manager, you are currently cherry picking commit DB00DA2. Fix conflicts and run GID cherry pick continue. So unmerged paths, all the stuff you can see here. So in GID status, we already checked here GID status. Sorry. On the active commands here, so you can see HTMLs stuff here. It's going to JD checkout. I'm just going to run the JD checkout dash dash DITHEIRS is to .html file command, and it executes. It's going to continue to the third step, which is the final step here. It's 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 my task to compare the child pick by first adding the previously configured item and then using the dash content option. So it's going to add list to here. It's going to continue the child pick. So you can see creating second list, and there are the conflicts. Then it's going to be committed. You have, as you can see, the modified the file path files details about the file that we have in modified. So that's all for the scenario 8 JIT version control. Just moving to the final step, which is scenario 9 of JIT version control. It's rewriting history. Okay, so it's based on step 4 steps. Then amending commit messages, JIT, rebase interactive, rewriting. First, we have to start with the beginning. So we enter the interactive rebase mode using this code, which I just executed. So you can see yes, you can see the commands P for pick, R for record, E for edit, S for search, F for fix up, X for exit. So that's all for the command here. And we can change the message using this command. So you can see it's on here. Again using VIM, edit the commit message to change. So you can edit the message here. So you can see right. Also try to change the letters code for something else. So discontinue it. Then I can't type. If you want to hit the command, use the event tweet logs. Into the step 2 is squash commits. The task is to do when we enter interactive rebase, we can specify that we want to modify the previous set commit using this command here. And then use this as well. So in this process, we have to run this task here, and when we enter interactive rebase, we can specify that we want to modify the previous 8 commit using this command. So as you can see, I just run that command. To do that, I have to use the command here again. The command. Okay, so then again we have to do this command task, and then to commit message, I have to use this. So as you can see, the files are here. Okay, so with the third step, which is reorder commit. So we want to reorder our last two commits using head to allows us to modify them. So ZU rebase the dash dash interactive head dash two command, and then we want to reorder the last two commits. So using that, we have to we can do it actually. So using name, simply reorder the lines, save and quit, and the commits will match the order. Yeah. So fourth step, it is split commit. So defining commit to split, here we want to split the previous commit, so we have to use this. Then we can use run this command. To execute this command, we have to use these commands as well. First, to do the saving, we have to save the work what we have done. So just saving the commands in here. And as you can see, out and the two commands using these commands. Right, so that's all for the GIT version control scenarios. Thank you very much for watching.